Hey guys, good morning and good evening. Thank you so much for joining in today. So, as a part of today's session, we'll be looking into the topic that's actually called as deep learning with Python. So, that's the topic of today's session. And as a part of our learning journey today, so that is this learning agenda. So, this is the agenda of this today's session would look like. So, we'll understand about the various applications of artificial intelligence, and then we'll look into the important definition. What exactly is this AI? What is machine learning? What is deep learning? And along with that, we'll also understand how this deep learning would work and what are the Python packages that you need to be aware of in order to learn the deep learning. And at the end, we'll also have a small hands-on session which will give you a taste as how you can create the deep learning neural networks using TensorFlow. And along with that, I'll also share you some tips as well, which will help you to learn by yourself as a part of self-paced learning journey. Okay, so that's the agenda of today's session. First, let's look at the applications of machine learning. So more specifically, we'll be looking into the applications of artificial intelligence. So some of the applications which we are already seeing in our real life, which are already present, are predicting the future, chatbot which we are using in almost each and every marketplace that is currently present. It could be Amazon, it could be Zomato, Swiggy, Flipkart, or self-driving cars, which is nothing but the driverless car, AI music composition, AI dream machine, AI eye doctor. So these are some of the applications of artificial intelligence. Now the question is, what is artificial intelligence? Well, the artificial intelligence is nothing but it's a theory and the development of the computer system which is able to perform the task which would normally require human intelligence. So the human intelligence could be like visual perception, speech recognition, decision making, and translation between the languages. So if I want to put it short, so artificial intelligence is development of system which would work and analyze the information just like we human do. So that's what an artificial intelligence system would mean. It will actually have the ability to analyze the information as well as take the decision just like we humans do. So in order to give you some of the examples of usage of artificial intelligence, so it's like an application or like machine playing chess, Siri, number plate recognition. So these are some of the applications of artificial intelligence. And when we talk about artificial intelligence, these are the areas that we can say which are under the specialization of artificial intelligence. So one is game playing, another one is expert system, one more application or the specialization that I can say in the field of natural language processing, where we'll be using the natural language, that means the way we humans speak, and process that information and understand what exactly is being conveyed in the natural language. And another area of specialization is neural networks, where we'll be using the deep learning neural networks in order to get the insight from the data or in order to find the patterns that is present in the data. And the another area of specialization of AI is robotics. So this is what an AI would be. Now the question is, okay, if this is AI, if you're new to this field of AI, machine learning and deep learning, so you might be wondering as, okay, if this is AI, what exactly is this machine learning or what exactly is this deep learning? Well, the next slide is going to clear all your doubt. So on top, if you look at it, I have my artificial intelligence. And under my artificial intelligence, I have my machine learning, which means I can say that this machine learning is a subset of artificial intelligence. And one thing that you have to remember is the difference between artificial intelligence and the machine learning is, in case of machine learning, I'll only have the ability to analyze the information. Okay, it will have the ability to just perform the analysis of information. Coming to AI, so this AI, as it is on top of my machine learning, so I can say that this AI has the ability to take the action as well as analyze the information. And coming to deep learning, which is the topic of our today's session, so this deep learning, as you can clearly see, it is under the machine learning, which means this deep learning is a subset of machine learning. Okay, So the difference between deep learning and the machine learning is, in case of machine learning, I'll be using the statistical based models in order to find the patterns in the data. But in case of deep learning, I'll make use of a network which is actually called as neural networks, which would work just like our human brain works. So just like we humans take the decision, so in the same way, we have the neural network structure which will take the decision just like we humans analyze information. So one thing that you always have to remember is, even in case of deep learning, it can only perform analysis of the information and it cannot take any action. So that's the difference between AI, machine learning, and deep learning. Okay. So now that you have understood what is AI, what is machine learning, and what is deep learning, let's do one thing. Let's get a formal introduction to machine learning, because you just had an introduction to AI. So let's have a formal introduction to machine learning. So when I say machine learning, we can say it's a type of AI or an artificial intelligence which provides the computer with the ability to learn from the data. And the best part is, we don't have to explicitly program over there in order to do the learning. Now here in this given example, that is the slide, so we have a problem statement. The problem statement is, I have to determine the species of the flower. Now in order to determine the species of the flower, I have some information. I have the various information like sepal length, sepal width, petal length, and petal width. So these are the four information that I have in this given data. And on the basis of these information, I have the information about species as, okay, so I have some collection of flowers. Just to give you an example, let's say I have some series of, I have some collection of flowers and I have measured it. So its petal length is 5.1, petal width is 3.5, and so on. And this flower belongs to this species of Setosa. Likewise, I have some collection of flowers. So each is belonging to different class. In case of traditional programming, I'll have to specify each and every role or each and every rule explicitly as a developer in order to determine this output, that is my species. So I'll have to say, okay, if my sepal length is 5.1, if the sepal width is 3.5, if the petal length is 1.4, or if it is petal width is less than 0.1 or so on, it would belong to the species of Setosa. Or if it is any other condition, it belongs to the species of Virginica or something. So as a developer, we'll have to explicitly code in case of traditional programming approach. But when we talk about machine learning, so what happens in case of machine learning is, I don't have to explicitly code, this is how my data would look like. So what I can do is, so I can just send in the data. So this is the table data structure that I have. I can send in this entire table structure for my machine learning program. And this machine learning program is going to learn from my given data set. And it is going to identify the pattern in the data. Now, while identifying the pattern, it will find the pattern between these four columns: sepal length, sepal width, petal width, for my target column of species. So that's the difference between traditional programming approach and a machine learning approach. Now, once I have done this machine learning, okay, so that means once the learning is complete, I can send in a new data and I can generate a new prediction. So that's the difference between traditional programming and the machine learning approach. Okay. Now, as I mentioned, so under machine learning, we have seen something called as deep learning. So the question is, okay, if my machine learning is able to learn the pattern that is given in the data set, so why do we have deep learning? That's the next question that we have. Now, in order to understand why do we have deep learning, let's look at the limitation of machine learning. So one of the limitation that we have in machine learning is, like whenever we are working with this data set, if it is higher dimensional data, then in such scenarios, my machine learning model will not be able to understand the pattern in the given data set in an effective manner. And another disadvantage is, while working with machine learning, so this machine learning approaches will not help us in solving the NLP or image related advanced tasks, because whenever we are working with natural language processing task or the image recognition type of task, we'll be dealing with higher dimensions of data. Just to give you an example, if I take an image data, if I have an image of the size, let's say 1080 by, so like 1080 by 1920 pixels, and if it is a color image, it will have 3 color channels, and in total, so I'll be having the number of dimensions as, let me just show you, 1920 into 1080 into 3. So 62,20,800 features that I'll be having for this single image. Now, when I'm dealing with this such data, which is of such higher number of features, my machine learning model will not be able to perform in an optimized manner, which will help me to identify the patterns in the data. So one disadvantage, as I mentioned, is the dimensionality. So that's one of the disadvantage. And apart from that, so in case of machine learning, so we'll be working with a statistical based model, which way that I'll be running from the data, it depends on the mathematical equation that I'll be using. So when we are talking about deep learning, we have a lot of flexibility. We can use multiple models. So in other words, I'll be having multiple neurons, which will help me to learn about the complex representations in the data. So that's the limitation of machine learning. Okay. So one, as I mentioned, is the dimensionality. And the another one is, yes, this is one more limitation of machine learning. So whenever we are working with machine learning based application or programming, in such scenarios, as a developer or as a data scientist, we have to perform the feature engineering. Now, when I say feature engineering, it's about extracting the information which are very important for my training purpose. Now, just to help you to get a visual understanding as what exactly is this feature engineering, let's say I have an image. Okay, so I have an image and this image contains tree. Now, in case of machine learning, my machine learning model expects that I have to manually identify where exactly this image of tree is present before I send it for further processing. So that is one of the example that I can say when I talk about feature engineering. But when we talk about deep learning, so the feature learning, this feature engineering will be taken care automatically. So that's another advantage of using deep learning over machine learning. So here it clearly says the deep learning models are having the capability to focus on the right features by themselves. So which means it requires very little guidance from the data scientist, and which will actually able to solve the dimensionality problem as well, which we actually face while working with machine learning algorithms. So the core idea behind working with deep learning is build a learning algorithm that is going to mimic our human brain. So this is what a deep learning advantage is. Okay, now the next thing that we are going to understand is how does this deep learning is going to work. So this deep learning, so I think we have covered this already. Let me just proceed. So whenever we are processing the information, so instead of using a single mathematical model, so we'll make use of a network that would look like this. Just observe on the screen. So as you can clearly see, this is called as a deep learning structure. And this deep learning structure will have something called as input layer. This is followed by some layers. As you can clearly see, these two layers actually represents my hidden layers. And we have something called as output layers. So whenever we are working with deep learning, we'll make use of this neural network kind of architecture, which has these 3 important parts. Okay, so the 3 important parts are input layer, hidden layer, and output layer. Now, in order to help you understand as what exactly is deep learning and how it actually processes the data. So just what we do in case of our human being is like, okay, whenever we have some information or if something happening in our outside world, we'll get that information through our sensory organs. So through our eyes, ears, nose, so we'll understand what is happening in our outside world. And once we get the details, so we'll send the details to our human brain, and my human brain is going to process that information, and it will help me to act accordingly according to the data that it has analyzed. Just to give you an example, if I'm driving my car, if something is in front of me, then that information will go to my brain, and my brain will give me an action that says, okay, apply the brake. So That's how our brain is going to analyze the information. In the same way, in our deep learning neural network, we have the input layer. Through this input layer, we'll be sending our input data. And through the hidden layer, we are going to process this information just like we human beings use our brain in case of deep learning neural networks. So we'll make use of hidden layers to process the input data. And just like we provide the output, like output in the sense as like, okay, apply the brake. That's one of the analysis that is given by human brain. So just like that, if I want to give the output from my neural network, we'll actually make use of output layer. So this is the overall structure of a deep learning neural network. So this overall structure is actually called as deep learning neural network. So now that you have understood the importance of deep learning and why it is preferred over machine learning, if in case as a learner, you're interested in learning this deep learning neural networks and understand how you can find the patterns in the given data set, so I'll recommend you to follow a structured learning approach. So here I want to present you the structured learning approach that we have at Edureka. Now, in case you're taking ahead with your self-paced learning journey, so I request you to follow along the same way because this structured learning approach has been created with the help of industry experts as well as the Edureka institution partnership which they have. So as a part of our course of deep learning training certification course with TensorFlow, as a part of module 1, you'll be learning how and what exactly is this deep learning. And this is followed by a hands-on session which will introduce to the concept of deep learning and how to work with TensorFlow library. This is followed by a module 2. In the module 2, you'll formally be introduced to the TensorFlow 2.0 and its various benefits and its various features that we have inside our library. This is followed by an in-depth hands-on session which will make you comfortable in creating the deep learning neural networks using TensorFlow. And as a part of module 3, you'll be learning about convolution neural network, which is one of the important neural network when it comes to processing our image data. And this is followed by an hands-on session where you'll be working in a hands-on manner and you'll be learning how you can process the complex image data and how you can derive the insights from the image data. Just to give you an example, after the completion of this convolution neural network, you'll be having an ability to process the image and work on complex problems like, okay, if I have a given image data, whether an object A or object B is present or not. So that's the level of depth that you'll be going when you learn about this convolution neural network. Now, this is followed by module 4, where you'll be learning about RCNN models, which is regional CNN models, which plays an important role when we are performing the object detection. That means for a given image, you'll not only be able to identify what exactly is happening in the image, you'll also be able to localize. That means you'll also be able to say where exactly that particular object is present. Just to give you an example of an application of this RCNN, so the face detection application or face detection feature that you would see in the Facebook, so it is based on object detection models. So you'll be learning one such models as a part of your module 4, which is regional CNN, which will help you to perform object detection. And this is followed by definitely an hands-on session which will be driven by the industry expert. And as a part of module 5, you'll be learning about Boltzmann machine and the autoencoders, which we generally use it for dimensional reduction as well as unsupervised machine learning approaches. And more specifically, this is one of the advanced topic of deep learning. All right. And this is followed by a hands-on session, followed by module 6. You'll be introduced to one more advanced or the most research field, which is called as GANs, where you'll be learning about generative adversarial neural networks, followed by the hands-on session. And module 7 is about how you can detect an emotion and a gender from a given image data, followed by introduction to RNN and GRU, which will help you to work with sequence-based problems. And at the end, as you progress, so as a part of module 9 and 10, you'll be learning about LSTM and create a complex project where as a user, you'll be able to upload a given image data and the deep learning model will be able to generate the captions that are present in the given image data. So you can think about it. So you can think about building an application where you upload your photograph and the deep learning model is able to identify what exactly is present or what exactly is happening in a given image. So that's how depth and that's how the like topics are actually covered as a part of your certification learning journey. Now, in case if you are going to the self-learning approach, I recommend you to follow the same way as I mentioned. This is one of the recommended approach in learning this deep learning, which has been recommended by the industry experts. Now, in order to perform this deep learning, you need to be aware of few Python packages. So in order to do this deep learning, one, you need to be aware of a deep learning framework. So it could be TensorFlow, PyTorch, or Theano. So you should be aware of at least one. So in our course of deep learning certification, as we have seen earlier, so we actually make use of TensorFlow library. So this TensorFlow is developed by Google in collaboration with Brain Team, and now it's part of Google itself. So it's popularly used in writing machine learning algorithms. And not only that, this TensorFlow offers various API which will make building the models a breeze. That means it's very easy to create neural networks and deep learning model using TensorFlow. And apart from that, yeah, so the some of the features of this TensorFlow are it has a very responsive construct. So we have the Keras API, which are tightly integrated, which will help me to process the information and create the neural networks. And it is flexible, it is easily trainable, and not only that, it can also perform the parallel neural network training. Okay. Now, apart from that, we have something called as scikit-learn. So under this scikit-learn, so we actually use this scikit-learn if I want to do any pre-processing on the data set, which is not supported by Keras or TensorFlow modules. So this scikit-learn is library associated with NumPy and SciPy. It's one of the best libraries while working with complex data. Some of the important features of scikit-learn are, so it will have various evaluation techniques that's called as cross-validation. It also has unsupervised algorithms, and it also has various functionalities which will help me to perform the feature extraction. And you need to be aware of NumPy library because NumPy is a Python library which we use it for computing scientific or mathematical data. It has various mathematical functions inside it which will help me to perform the mathematical analysis in a faster pace. Some of the features of NumPy are it supports multidimensional arrays, it will help me to perform the numerical analysis, and it's very intuitive. And we have something called as Theano. So Theano is another deep learning framework, which we can use it as an alternative to TensorFlow. So it's a Python library which will allow us to define, optimize, and evaluate mathematical expressions, which involves multidimensional arrays in an efficient manner. So when I say multidimensional array, sometimes you will see people using the terminology that's called as tensor. Okay, so this is about Theano, and if I want to name some of the important features of Theano, it has very tight integration with NumPy, and the best part is it makes use of GPU, which will gives us the speed boost, and it supports extensive unit testing as well as self-verification. Now, there is one more library that's called as Keras. Now, with the TensorFlow 2.0, so Google team has made sure that we have the tight integration between TensorFlow and Keras. So this Keras, it actually simplifies the implementation of neural network. So it provides a high-level API, which I can use it to build a neural network in a more efficient manner as possible. And it's very easy to create neural networks with the help of TensorFlow and Keras API. Now I'll be showing you in a hands-on session as how easy it is. So to name some of the important features of Keras, so it runs smoothly on both CPU as well as GPU. It supports all types of neural network, and the best part is it's Python based. And one of the another application that I'll be doing whenever we are making use of deep learning neural network is we'll also be working with text data, especially while working with the models like RNN and LSTM, which is a sequence based data. So in such scenarios, so as a learner, you should be aware of NLTK library, which will help us to perform the natural language data pre-processing. So NLTK is a natural language toolkit. It is an open source Python library which we use it for natural language processing, text analysis, as well as my text mining. So some of the important features of NLTK are, it will help me to perform the analysis of the natural language text analysis, as well as sentimental analysis. So these are some of the important libraries which you need to be aware in order to get the best out of the neural networks. Okay, and let's have an hands-on session. Now, in order for you to practice along and learn the same, so I'll show you how you can learn from the tensorflow.org, which is the official website of TensorFlow. So if you go to this website of TensorFlow, you can click on Get Started with TensorFlow. And from here, you can select See Tutorials. And here we have various tutorials. I'll select as Quick Start for Beginners. So this TensorFlow tutorial, that is a hands-on tutorial, hands-on example tutorial that I'm going to show it to you. So this has been created on TensorFlow 2 version, which is one of the latest version that I'll be using. And this uses 𝐾RS library. As I mentioned already, TensorFlow has a tight integration with the 𝐾RS library, so which will help me and which will make my life easy while creating a neural network. So here in this example, we'll load the data set, we'll create a neural network, and then we'll perform the training. Okay, so when I clicked on over here which says as run in Colab, so this will actually start a Google Colab session for me. Now on right side, I'll click on connect. So this will connect this notebook instance to my Google Cloud in the backend. So once the connection is complete, I'll go ahead and execute this cell. In order to execute this cell, I can click this run button, or I can make use of the keyboard shortcut Shift plus Enter key. So I'll just execute this cell. So here I'm displaying the version of TensorFlow which is currently running in my Google Colab server. So the current version that is running is 2.7. Next, we're going to get the example data set. So this will download the data set, which is called as MNIST data set. And once I download the data set, here I'm creating my neural network. Now to create my neural network, I have made use of 𝐾RS API. The reason that I'm saying it as 𝐾RS API because I've mentioned as tf.ksrs.models.sequential. I'm creating my model as sequential, and then I'm saying it as my input shape is 28 by 28. That means in my input layer, I have the shape of 28 into 28. And this is connected to my hidden layer, which has 128 neurons. Okay, I'll say it as H1, which has 128 neurons. And this is connected to some dropout layer, which will help me to reduce the overfit of the data. So overfit is one of the topic which you might be aware of from the machine learning. So with this will help me to reduce the overfit on the data. And at the end, I'll have my output layer. So this output layer has 10 neurons. I'll say O, and this has 10 neurons. Okay, in this way, we can build a neural network. So as simple as that, I have to define my model as sequential, and I'm adding my individual layers over here. So once I do it, so this will generate my neural network, which is my model. And once I have the model defined, I can directly run the predictions as well. So here this is running the prediction. And on top of it, here I'm using my softmax mathematical function in order to get the output in terms of probability. Okay. So along with that, while working with neural network, we'll make use of a function that is called as loss function. So this loss function is going to help me to train my model. And here inside my compile method, we'll specify our loss function, optimizer, and the metrics. So once this compilation operation is complete, we can directly go ahead and perform the training. So in order to do the training, I can just call fit method and specify my training data. So this will perform the fit on my given data set. And once this fit is complete, I can directly go ahead and evaluate my model to understand as what is the performance on the model. So at the end of my training, so currently it's at 4th epoch, let's wait for 5th epoch. So epoch is nothing but the iteration. So at the end of my training, I'm getting the accuracy as 97.56% of accuracy. And once the training is complete, so here I'm checking the evaluation. So what will be the performance of this model on the test data? Okay, so on my test data, so I'm getting the accuracy as 97.63%. So in this way, we can build a model using TensorFlow. In order to get the complete understanding and to try out from your end as how you can actually work with deep learning models, let me do one thing. I'll show you an example. It's called as a neural network playground by TensorFlow team. So it's a network playground. So here you can, this is the right side. On right side, I'm having the complex data. So here you can just test out, okay, by selecting the number of neurons. So here I'm getting one neuron, and I can set various parameters of my deep learning model by specifying activation, regularization, what is the type of problem and the learning rate and so on. And I can begin my training by clicking on this play button. Now, in this way, I can try out and just experiment, get a visual idea as how deep learning models can help me to find the patterns in the data. So here in this example, by using a single neuron, I'm unable to understand the pattern in an effective manner because on the top region, it says it belongs to the blue data points, that is blue region. But I can see that in my blue region, there are some orange data points as well, which means one neuron is not able to understand the patterns in the given data set. I'll do one thing, I'll increase the number of neurons to 3 and I'll again begin the training. So once I increase the total number of neurons to 3, so let's see how does the performance. So the performance is slight better. Okay, yeah, finally it has been improved. So by using 3 neurons, see, I'm able to learn this complex representation in the given data set. So my blue data points is separated from the orange data points in an effective manner. So this is just to demonstrate as how deep learning models can help us in finding the complex patterns in a given data set. So I have shared this link over here in the chat window. You can click on that link and practice it at your end as well. There are some various example problem that is given by TensorFlow team. You can increase the number of neurons, number of layers, and start training. Check out various values in order for you to just to get a taste as how does the neural network training would look like. Okay, now along with this, you can also make use of TensorFlow official documentation to learn more about the same. All right, folks, so this was about performing the deep learning neural network using Python programming language. So I hope you learned something about TensorFlow in today's session. So thank you so much for joining in. I look forward to seeing you next time, guys.